Hi, good morning, everyone. I'm Carla Balo from the Center for Automotive Research, and I'd like to welcome you to today's webinar with the Altair team on whole vehicle lightweighting and module lightweighting. We have a lot of great presentations for you from some of the winners from last year. And as the slide show that went through earlier showed, the nomination submissions are due in May. And we'll remind you of that date throughout the presentation today. I'd like to introduce the moderator for today, Mr. Richard Yen. He's the Senior Vice President of Global Automotive and Industry Verticals team at Altair. Take it away, Richard.
Thank you very much, Carla. Let me show my screen here. Can everybody see my screen okay?
Yes.
Okay, thank you very much, Carla. Very happy. Good morning, everybody here. And today we are going to talk about the full vehicle and the module lightweightings. And we are very fortunate to invite the guests as a panelist from past winners. So while we are going through this, first, I would like to play a video and really document what we have done in the past and what kind of success we already accomplished through those years.
Much like the title Enlighten, because it enlightens us on new technologies.
They're like a peer to me and to my engineering colleagues, so it's even more of an honor to have a group and a company that's made up of engineers give us an honor like this.
It's important for automotive companies to reduce vehicle weight because not only do we want to give customers the cars that they want from a ride and handling point of view and an enjoyment point of view, we also want to give customers cars that meet the sustainability challenge and get better gas mileage and better CO2 reduction.
We consider the Enlighten Award as the Oscar of lightweighting. So for us, we've been following that for years.
We are going to brag about this to all our customers. We're putting it on our website. We're very proud of this. We had the CEO here today. So we're going to really brag about winning this award.
Thank you. So for this panel discussion here, I think we roughly have 55 to 60 minutes. And here's the rough agendas that we are going to go through today. So first, I'm going to give you a little bit introduction of the Enlighten Award. And as we are very fortunate to have 3 guests, from Toyota, from Continental Structure Plastics, and from Shiloh Industrials. And then we will go through their presentation, and hopefully their stories, present us a winner stories to give us a little bit inspirations. And then please, you can ask any question and type into the questions, and then we will try to go through your questions. And once they finish their presentations, that we will start to, have a conversations and really talk about what are the concerns, the questions, and what is the contents the panelists presented. Then I will have a little bit close remark, and essentially it's encouraging everybody to enter this year's lightweighting. So before we go into that, for the introduction, I just would like to very, very quickly to introduce Altair a little bit. So Altair is a global technology company that established in 1985. And through those years, Altair has been growing very, very well. And now it's listed at the NASDAQ as a public company. And Altair's vision really to help the customer transform their decision-making process by leveraging the converse of the simulation, high-performance computing, cloud, and artificial intelligence. In order to achieve those through the years, Altair has been, building the 3 very, very important pillars, from the traditional design, modeling, visualization to solvers, and then get into the data analytics and the AI. Later, we also get into the Internet of the Things for the connectivities and gathering the data. And certainly high performance computing is one of the strong pillars that Altair has been started earlier. With those success, without the partners, strategic partner that join us, we have a 150 partners program join Altair as the offerings that we could not really achieve this success. So Altair really essentially is having a really broader solutions and portfolios to offer to engineering societies. So for the Enlighten Award this year, actually, is going to be enter our 9th years for Altair Enlighten Award. And Altair has been very, very happy working with CAR, collaborate with CAR, and have an independent judges to judge those entries. So just want to remind everybody here, the date is the May, end of May, May 31st. Is going to close the entries, and then we will go through the judge and review cycles, and CAR is going to help and host the judging panel discussions and really select the finalists. And then we will present those awards in CAR's MBS on August the 4th. So what is the difference for this year's award? That we understand that through the years, Altair Award has been already extended, not only from the 4 vehicles, but also get into the module, get into the enabling technologies and future of the lightweightings. We understand the OEM can, to achieve their goals, that would require the supplier's support and the people who has a visionary on the lightweighting solutions. So that we are adding, the module and adding the enabling technologies and the future of the lightweighting. This year though, because through the conversations through the years with the OEMs and also with CAR, we realized that actually the sustainability is a much broader issues that we have to address. And oftentimes lightweighting is only one of the key elements. So we add 2 categories. We replace the 4 vehicle lightweighting to 2 categories. One is sustainable products, and one is a sustainable process. So sustainable product essentially, is a product really can help, and the whole process, considering the air emissions, considering the recycling, considering the material saving and cost saving, etc. So during those reviews, we already post the judging criteria in our website. So please come to our website to take a look at those and download the form for you to submit the entries. And if you have any questions and need help to submit into these categories, please let us know. We will be very, very happy to work with you and then to go through those required information need to be entered. So next, I would like to introduce our speakers and the panelists this morning. And those speakers that have already won the award in the past, and like Toyota, they won the award not only in 2017, they also won the award last year. So that I would like to invite the JP and from Toyota to present, to share us their vision as well. We also invite the Continental Structural Practice. We have Hugh to join us. Hugh is the Executive Director for the Advanced Research and Development. And then Hugh is going to share with the winning products that CSP has won in 2019, which is the Carbon Pro, the truck box. Then we also invited the Shallow Industries that have a GM as a director of the product technologies coming to share with us their innovation of the laminated oil pen with the aluminum. So without further ado, I would like to have a JP to present, how they see this, the changes in the industry and how, the winning products, the process, so that can inspire us as well. So JP, please take away, and please also briefly to introduce yourself.
Okay, Richard, thank you very much. My name is JP Flaherty. I'm from PMNA R&D. I work in basically technical planning and strategy type work at the R&D office here in Saline, Michigan. And one comment that I'll make just as a point of fact, for last year's item, the seat back that was a Enlighten Award winner, the actual leader of that was Todd Muck, my colleague. And so I want to make sure that nobody tries to give me credit that's not warranted. That was Todd's doing. So let me go ahead and share my screen here and we'll get started. Okay, can you see?
Yes.
Okay, very good. So today we're talking about full vehicle and module lightweighting. And so I wanted to start off with an overall historical trend line about this, lightweighting endeavor. So it starts off with the 1970s, the oil shock and CAFE regulations that really, in hindsight, incentivized small cars. But, things changed, the market took over, and basically, the consumer's voice was clearly understood when we got to the second round of CAFE standards in the Obama era. And at this time, the standards were footprint-based, which could accommodate a full range of vehicle sizes and forms in a much more better way, or a better way. And this introduced lightweighting as one of the key components, because if you want to make a bigger car, you may need to make it lighter to improve the efficiency. So, today we're entering into a new era with, new regulatory and consumer demands, shifts in the market. And really, things are evolving to not just be thinking about tailpipe, but rather the full life cycle sustainability, the ESG. You can see where, you know, that's demonstrated by the Altair Enlighten Award introducing the sustainability portion. But yet, through all of this, the engineering mission remains that success comes through good product and customer satisfaction. Certainly, that's the approach of my company. So, to pursue this efficiency, you know, overall quest, Toyota's focus has been powertrain technology, and this started really with the launch of the hybrid from the Prius concept in 1995, in introduction of the Toyota hybrid system, which has now proliferated across our lineup. And, you know, the commitment from Toyota to continue to expand powertrain electrification to where all vehicles worldwide will have this as an option by mid-decade. That's our goal. And in addition, as we look further down the road in the future, you know, we recognize that there are additional powertrain advancements, namely fuel cells, which you can see even today with the Mirai. And, you know, recently the company has made announcements about new global vehicles that will be launched with a fully electrified powertrain system. So then if we talk about weight reduction and some achievements, well, we have the first Altair Enlighten Award that we won in 2017. This is for the resin liftgate for the Prius Prime, which is the plug-in version of the Prius. And in this case, the technology is a CFRP inner panel with glass fiber reinforced molded SMC structure that's 40% lighter than equivalently sized aluminum. And, you know, more importantly for us, gives the customer benefits, unique styling with aerodynamic advantage, and, you know, mass offset that allows larger battery and thus longer range for the driver. In 2020, we again won an Altair Enlighten Award, this time for a project that was developed here locally within TMNA R&D, and also with a very strong collaboration with our supplier partner BASF. And this is the resin seat frame for the Sienna minivan that utilizes glass fiber reinforced resin structure that's 30% lighter than the steel, the prior structure. And, you know, in this case, we were able to manage cost by considerable reduction in part count. We're able to integrate many subcomponents into the structure itself. And in this case, really the key advantage for the customer is ease of use. It's very light and easy to fold and unfold these third row seats in the new Sienna. And then coming next, what's behind the curtain? Well, future product. I can't talk about future product, but I can say that we are definitely working on new and compelling innovations that will be revealed in due course. And, you know, following the same pattern with weight reduction focused on the customer and innovation to manage some of the side effects of that. So finally, let's talk a little bit about kind of big picture and how we bring that down to our local operations and R&D. You know, Toyota is on this quest to reform our company to become a mobility company. And, you know, there's lots written about this and lots to see. There's all sorts of interesting things going on within the case definition. And really, this is a revolutionary transformation, not just for our company, but for the industry as a whole, with change happening everywhere that's affecting, you know, all corners of the company. And that does include us. And you know, we have reforms that we are working on to, you know, basically manage this change in our core vehicle development work. So, one of the ways that we are doing this reform activity is really looking at 4 different categories. Number one, we never will stop identifying and closing quality gaps and maintaining that customer first mindset. Toyota realizes that this is the secret to our success, and we have to maintain the quality and safety and these attributes of our vehicles that customers love. But then we also think about, where do we have the approach just right? Where can we say it's good enough? And also, where do we need to exceed the customer's expectation? What attributes, what design elements do we want to overshoot the requirements and really make a strong impression and strong value for the customer? And where it gets interesting is the 4th one, where we want to challenge the status quo when internal requirements don't align to customer needs. So, we have to recognize that we're a legacy automaker. We have a very long history and a thick rule book, and it's served us well. However, as time changes, technology changes, customer expectations change, competitors come in with new, clever and innovative things that maybe we're challenged to do because of our kind of strict ways. So we need to challenge ourselves with new thinking that can, change our approach and enable innovation for things like weight reduction. So this is something that we've been working on for a few years now, and we've involved our suppliers in this activity. And so this is a big part of our ongoing effort. So finally, key takeaways: we will continue to maintain a strong focus on innovation to meet the challenges of a rapidly changing automotive world. We remain committed to fuel efficiency in our vehicles and sustainability across the enterprise. We will pursue weight reduction where it makes sense and where we can utilize it for customer value. And of course, we will always continue to collaborate and build the relationships and the innovation with our supplier partners. And that's the end of my presentation.
Thank you very much, JP. Actually, while you're presenting this, a question just come up from my mind is that, as an OEMs, there are so many factors that need to be considered, not only the lightweightings, but also the cost, the manufacturabilities, the material, that type of stuff. Can you share with me, just touch briefly on how an OEM or Toyota make decision to make those process going along when you initiate a vehicle program?
Yeah, so, a new project, a new vehicle is, of course, a massive challenge, and there's, stakeholders from end to end that all have to weigh in and participate in that. So, if we look at, that list of items that you ticked off, cost, of course, has to be managed. It has to be considered. We're in business to make money. We have to continue to make sure that we are sustainable going forward from a business point of view, and that means that cost has to be managed very carefully. Weight is, there are many different ways to look at weight reduction, but one of the most important things for the automaker's point of view is really it's relative to the inertial weight ranking that's used for fuel economy measurement. And so, planning early on, you basically fix your strategy based on inertial weight rank, and you're really trying to hit that target. And so incremental weight reduction might not have so much effect, to save a kg here, a kg there, not so much effect on fuel consumption or GHG, but there you're talking more about mass offset to allow other equipment on the vehicle. So, you know, it's quite a developed challenge, you know.
Yeah, understand. So I think it's a very sophisticated philosophy and issues. We leave some of the questions, you know, during the general panel discussion. I'm seeing some of the questions coming in relevant to your presentation, but I want to move forward to Hugh, so that let's finish the presentation and then we come back to discussion as a panel.
Sounds good.
Okay, thank you very much. So Hugh, please take away, and thank you very much for joining us to present the CSP and the winning products. Hugh is Executive Director for Advanced Technologies in CSP. Hugh, could you please show your screen? Yep.
Give me 1 second here. I'm just
Thank you.
Apparently I started at the wrong end of the presentation. Okay, I'm Hugh Fran. I'm the Executive Director. I run our Advanced Development Center up here in Auburn Hills, Michigan. I've been with the company for over 38 years now. We've been growing significantly since Teijin purchased us. We were acquired by Teijin in 2017. Most of our products are thermal set products. However, we're growing into thermal plastics as well and other materials. We have 14 facilities in North America, 3 in Europe and 2 in China, with over 4,300 employees right now. So we've been growing significantly. This just has a quick picture to give you an idea of where most of our facilities are. We are truly a global company. We have our Advanced Development Center here. We also have one in Japan, and we have one also in Europe as well. So we're able to interface with our customers and to work on developing new projects. Some of the R&D centers that we have, though, are specific for just developing material. The facility that I have here, we also spend a lot of money on processes and equipment. Our product capabilities are—
Hugh, just so, sorry, are you showing your presentation?
Yeah.
Oh, okay. So I think you did not hit share.
Let me take another look here.
Yeah, please.
Sorry about that.
I know you are telling a good story, but just haven't seen the screen.
But it's not going with the presentation. And hold on. And very sorry about that. Let's try this again. Very sorry about that, guys.
Yep, can see it now. Thank you very much.
There we go. I thought it was moving along with that. So let me back up here. So our product capabilities, again, many apologies. Battery boxes and carriers is turning into a large business for us. Pickup boxes, we do many different pickup boxes for many different customers. The one that we're going to be talking about here is GM, the Carbon Pro. We also do pickup box for Toyota, we do for Honda, and also we're in development with several other OEs for some pickup boxes. The Class A body panels is huge for us. Marine outboard motors, we do all the Mercury Marine outboard motor covers for all their engines. A lot of underbody components, structural components, and interior panels, as well as building and industrial components. Carbon Pro, which is the main focus of my presentation here, goes way back to 2011. It was between General Motors and Teijin. GM and Teijin actually located their engineers here in this facility that we're in right now for our development center. We did the trials, we learned about the material here. And then CSP joined the development when Teijin acquired us. One of the big reasons that they acquired CSP was our manufacturing experience. The other thing I should mention that we actually are probably one of the few development centers that actually has a 4,000-ton vertical press in-house, as well as several other presses. CSP was a tier 1 for the Carbon Pro box. We produced that down in Huntington, Indiana. It's 17 miles from GM's Fort Wayne assembly. And we further streamlined the development process between CSP, Teijin, and GM. Also, I do, just like JP Flaherty, I do want to call out, I was not one of the main people for this program. It was Eric Heiss and Steve Plazarski were our main guys who basically led the Carbon Pro box on this development. Cerebo is a thermoplastic material. It's a nylon material with 35% carbon fiber. It has, it's 1-inch random carbon fiber mat. It has isotropic properties. Isotropic meaning that it has basically the same strength, stress in all X, Y, and Z directions. And we also use some of the offal from the material we grind up, and then we use that to injection mold some of the extra pieces for the box as well. So it is fully recyclable material. We do this, we process this under a minute in a compression molding vertical press down at our Huntington, Indiana facility. The quality levels, because of the tools, were very consistent and very dimensionally stable. And we processed this in under a minute. This was the industry first carbon fiber composite pickup box. It has very high strength and durability. It's UV resistant. Lightweight, it's 62 pounds less than the comparable designed steel bed. So it's a huge weight save. Also, by using this, you don't need a bed liner with the pickup box. I'm going to show you the video that I have here very quickly. And with that video, you can see that there's no damage to the box really, and you don't see any holes in the bed. Also, those drums were filled with water. This really exceeds the requirements of any pickup truck that's out there. I just want to quickly talk about, because I mentioned we do a lot of Class A body panels. We basically do the complete Corvette outer panels, including the doors, hoods, roof. You can see a sample of all these parts. We've been doing Class A body panels for the Corvette since the C3 model, and we're now up to the C8 model. And then we have a lightweight, low density material that we use for the 24 panels. It's a 1.2 specific gravity thermoset material that's significantly lighter, in the neighborhood of 60% lighter than if it was a steel design. Also, we're now working on honeycomb panels, and we're working on extreme shapes. Many people are working on just like load floors for honeycomb panels. We're working on Class A exterior body panels that we're in development right now on. that have shape, but it ends up being even lighter than regular SMC panels because we're also, in terms of lightweighting, we're able to down gauge the outer skins, whether they're SMC outers or thermoplastic outers. And as we down gauge, it reduces the cycle time it needs to cure those materials. And all of these processes are under a minute in cycle time, which greatly reduces the cost. This just gives you some more information on some of the composites for the honeycomb panels. We've been playing with many different types of outer skins, whether it's, like I said, thermoset, thermoplastics. We've even played with carbon fiber outers. And it's generally a very strong part that now we even have that's capable of going through an E-coat oven. And this just gives you an example of some of the shapes that we can mold into the part, but we can also create unique shapes and do a complete floor pan if required. That's the end of my show.
Thank you, Hugh. You know, while you are showing those, some of those, the new material, especially say, for example, like, you know, Carbon Pro,
yes,
that is the industry first. You know, how as a company in CSP or Teijin convince the OEM to use new material because the car could last a long time and have to go through so many stringent use cases?
Really, it depends on the design requirements of the customer, because for the last 20 years, and I'm going to use Toyota as an example, we supplied the Toyota Tacoma pickup bed. It's a medium duty truck. We've been supplying a composite SMC pickup bed for that for the last 20 years. It really depends on the customer's requirements. GM went out and put requirements together that way exceeded anything else. So you probably remember the commercials between Ford and GM dropping the blocks in the back of the beds, and they were putting holes in the beds. So they wanted to have something that exceeded the military grade aluminum that you know, Ford had, and then, you know, the steel bed that GM had. So they wanted something that was way over the top for that. And we were able to meet those requirements with the Carbon Pro box. We do similar tests though, even on like the Toyota pickup box with like drum drops and other block tests and shaker tests. But every customer has different requirements. We do a box for Honda, which is part SMC and part thermoplastic for the sidewalls.
I see. So different application could come from different combination of the materials.
Yeah, it's really customer specific for what they require.
I see. Thank you very much. So let's move to Jim from Shallow Industries, and Jim is the director for the product technologies, and he is going to share with some of the innovation process for this laminate aluminum oil pan. Jim, please take away.
Thank you. Let me share my screen here.
Yep, we can see your screen. Yep.
Let me get in presentation mode here.
Yep, looks nice. Thank you.
That's good, thanks. Yep, I'm Jim Evangelista. I'm the Director for Product Technology at Shiloh Industries. And product technology is our R&D and our innovation type processes that bring new products and processes into the market here. Shiloh, as a company, the vision is to create innovative solutions for sustainable mobility and a better environment. And we've been doing this now for quite a while, even though now you're starting to hear more and more about it. We've been focusing on a lot of environmental type stuff. So we have sustainability in our operations, and what I'm going to talk about more is just sustainability in our technology. Over the last years, 100% of our R&D has been invested in initiatives that we really want to focus on benefiting the environment. We have technologies which we're going to talk about. Shiloh Core is our laminate material technologies, specifically for improving NVH and lightweighting. We also have developed aluminum laser welding which really can benefit. It can provide parts that were lighter weight and lower cost, actually, at the same time, which is pretty interesting. Company is global reach, as most of our companies out there, the competitors and everything else. So we won't spend too much time on that one. The thing that I like about Shiloh is that we are basically material agnostic. We don't try to force any one material into a solution. What we seek to do is put the right materials into the application that meets the product cost, weight, and performance targets, and meets a better business case, which is what we're always going to partner with our customers to try to develop that stuff. The parts that we're looking at, really, we are also agnostic to the powertrains, things that we've done for internal combustion engines. We can also do a lot of stuff that we're moving for battery electric vehicles, for chassis and body structural type components. So it's pretty exciting times as the times change and we see more and more of the battery electric vehicles coming in. There's a lot more opportunities out there. To do this, we have a innovation process, and that's basically what we do is we take the process and we ask ourselves, hey, is the concept technically feasible? Does it fit our strategy? And then the most important thing is, what's the value proposition? It's going to make a business case, and are we going to be able to price it properly to get market acceptance? This technology innovation roadmap we call STIR, and basically it's a phase gate type of approach. At each one of the gates, as we finish a phase, we ask those questions again. Is the market still there? Is the technology still there? Have we now looking at from a production standpoint, are we going to be competitive from a pricing standpoint where we need to be in the market? And that's how we look at all of our innovation as we come down. And the most important thing is the phase 3.2 is the pilot production. How do we scale up something that we did in the laboratory to make it really something that's profitable and adds value to the environment and consumers? The product that we're going to talk about here was a 2019 finalist. We didn't get the award. We were kind of sad. You know, it's the way life is. Our customer came to us, and we do a lot of oil pans. We've been doing these for probably 30 years now, making laminate oil pans. We've developed our own proprietary laminate, and they came to us and said, listen, we want to reduce weight, we want to reduce noise, we want to also really match the thermal expansion between a cast aluminum skirt that we're putting on the engines now and the oil pan itself, which will improve sealing durability. And so they came to us and they said, you're making steel laminates, can you make an aluminum laminate? We looked at it and we said, wow, you know, there's a lot of challenges to do that. Anybody that's tried to form aluminum understands it reacts very differently than steel. Not that it can't be done, but it's different, and there's a big learning curve to that. So not only on top of the aluminum material itself, we had to say, well, will our adhesive, is our polymer going to stick? Is it going to adhere? Is it going to have wet out? Are we going to get the same damping properties for that? And then how do we do that? We have to take that laminate now that we've made, and we have to develop all the forming simulations to be able to say, what is a tool? Can we actually form this part? These oil pans are really tricky from a forming standpoint, even in steel, because you see they have a lot of material drawn up on one side and then not a lot on the other side. And how do you control that material flow going into the tooling? And the third and final challenge that really came apart was that in all the steel oil pans, the drain plug and the nuts and the things that we put in there, we just basically resistance weld in there. So we can't do that with the aluminum laminate. The current that takes to actually try to spot weld or ring weld those parts into the car will take too much current, and that current then will basically vaporize the laminate in between the two sheets of metal, which then causes a lot of porosity. So there was a lot of development that went into all different things of how do we attach that. We finally came up with a pretty novel solution to the problem, which is now into production. So it was challenging, but it was kind of fun at the same time. I think that's pretty much where I am at this point in my conversations. If you have any questions. Richard, you're on mute.
Thank you, Jim. Jim, I have a question. This is the industry first again, with the new process. Is your company has a good process to help to really warrant this innovative process so that you can really go through all the challenges that you just mentioned about?
Yeah, what we do with all of our innovation processes, and this was a good one because there was a customer pull for this. The customer came to us and they said, "Hey, I want to have an oil pan. I want to make it out of aluminum laminate. And what are the challenges?" And so we go back to the process that we had, which is this idea. We evaluate the idea. We say, "Hey, is it technically feasible to do this?" We said, "Well, yeah, we think it is." So we do some coupon development, and we come through. Then we go through and we say, "Okay, if I could do this, what would the process look like? About what that process, how much would that cost us to do that? And is it really feasible from a marketing standpoint to price this product into the market?" With this one, it was really actually interesting because if you see the note there, it came out to be cost neutral. So when you looked at it, the steel oil pans came in, they're heavier, they have to be e-coated from a corrosion standpoint. So we removed the e-coat. We also had a lot of large resistance welding type cells that we put in there. And the solution for putting the drain plug in there was actually a riv nut solution, which was a faster and a lower cost option. So when you put it all together, even though the aluminum material itself is a higher cost per pound, when you look at the total solution for the module, it actually was just about cost neutral for them.
I see. Thank you very much. And let's actually conclude the presentation here. The next that I would like to get through is that I'm seeing quite a few questions coming in, and let's just pick some of those and to answer those. I think a lot of questions on the composite materials, and also one question on the geek praise that Tesla has done. So let's go through those. This is quite interesting. Hugh, when you are presenting the material for the body panels, one of the audience is interested in the repairability. How are you going to really make it easy for the users, and how costly it could be?
Actually, if you're familiar with Bondo, the repair material is basically the same resin system that we use for our Class A body panels. It's a polyester based and fiberglass with 1-inch chopped fiber. So for like the Corvette body panels or the Class A body panels, if it's small damage, one, they're very dent resistant. Number two, if you did have damage, you can repair it with simple body shop guys are very familiar with how to repair and work on that. Even the composite pickup boxes, we actually at one point had a repair kit for the Toyota pickup box. And then we found that that box was so tough that there was really no need for that repair kit. But most of the body shops, when they're repairing Class A body panels, because we also make the Jeep roof, it's a polyester resin and glass. Very easy, very familiar to repair that.
Thank you. Another question I think probably is suitable for JP and Hugh to answer is that, through the presentation, we are seeing a lot of, carbon fiber or glass reinforced composites has been using in the industry more and more. And what's your comments on those in the futures, and what is really depends on so that the OEMs can really take it on and apply to a real vehicles. So JP, could you please make a comments? Then we go to Hugh to make comments on those.
Yeah, I think, you know, you can see an example with the Sienna rear seat where we were able to consolidate and in that structure reduce on the order of, you know, 10 to 15 subcomponent parts by integrating into one panel. So that's a big advantage from a cost point of view, a simplification point of view. And then I think there may be other applications where, you know, your load cases or the specific part, if you can, just like we see from the Carbon Pro deck, you know, the truck bed, if you're really aiming for extremely high performance, you might be able to utilize carbon fiber in a way that provides that advantage to the customer. So I think those are two cases that I would mention.
Yep, thank you, Hugh.
Well, we are the second largest carbon fiber supplier in the world, but carbon fiber is very expensive. Most of our we do have some carbon fiber products out there, but the cost has, just because the amount of energy it takes to make carbon fiber and for it to be on the mainstream, it still seems like glass is our #1 material, fiberglass. Yes, we can get very close to the same strength, but we're also finding that we're mixing the carbon fiber in areas that we need it. Because carbon fiber by itself is, like, I got to repeat myself, just it's expensive. It's great for fighter planes and race cars, but as far as, you know, putting it on every Camry that's out there, it's probably a little bit prohibitive. But we have glass solutions, and we try to keep our material costs in line with where aluminum is. But when you go into carbon fiber, you're talking, you have to really have the requirement need to have the carbon fiber.
Thank you, Hugh. It's a very, very good comments. Actually, I will switch the topics to the aluminum questions related to aluminum for Jim. You know, Jim, we are seeing, you know, the pieces of the casting become bigger and bigger, you know, from high pressure die castings. And we are seeing the Tesla using the giga press, you know, the huge pieces across the vehicles. And I would like to get a comment first from Jim and then get from JP's perspective as well. JP and I actually had some conversation on this in the past. So that would be interesting to learn from the OEM perspective. So Jim, please go ahead.
Well, we do a lot of the of castings too. We don't have presses that size of the giga press, but we do have presses that go up to like 4,000, 4,500 ton for aluminum and magnesium die casting. And there's an advantage in some cases to combine all those components into one thing. But there's also disadvantages when you look at some of the, from my standpoint, some of the variation that you get in castings that is just inherent in the process. You're going to get porosity, you're going to get inclusions in there, and they're going to be, they're going to float around in assembly. So you got to take that into account and say, can I control that? How am I going to control that from a process standpoint? We are really critical structural components. We're 100% X-raying, and we look at the amount of porosity, the amount of different inclusions that we get, and make sure that they're not in those critical areas. And I think as you get to these bigger and bigger assemblies, I've been watching that giga press and looking at what they do. And I believe what they're doing is they're casting in the F state. They're not heat treating it, but they have developed their alloy, like we're developing alloys, that will then allow them to, it has enough elongation to assemble it in the vehicle, but then as it goes through e-coat and paint bake, the aluminum then it changes, it drops in elongation, which you don't need anymore, but it increases in strength to get there. But you still got to look at, from my standpoint, you know, what is the variation that you're going to get in those parts? And in a lot of cases it works. In a lot of cases, you got to step back and say, no, I'm going to do it a little differently. Mm-hmm. I'd like to hear JP's comments on that too, because that's where we see it coming from talking to our customers.
Yeah, JP, please.
Yeah, I'm not going to say much because that's not an area where I claim expertise. But you know, as an observer, it's an incredible risk and innovation by Tesla to proceed with the gigacasting, and it's fascinating to watch. You know, obviously, you know, the legacy automakers are going to continue to try to leverage their existing manufacturing footprint and try to get as much as they can out of those investments that they've already made. And you know, whether or not this is pointing to the future, I guess we'll have to wait and see.
Okay, I think you know, I probably have one more question related to metallic gas issues. You know, an audience asked about the scale up in the futures. How do you see the usage of the aluminum compared with the high strength steels or ultra high strength steels? You know, do you have any vision per se, or see how this is going to grow in the futures? I would give JP to make comment first, and maybe the Jim.
Yeah, so I'd say it's the same answer that we've seen for a long time: the right material for the right application. And you know, the steel industry is making advancements with new grades in Gen 3, and you know, there's opportunity there to you know, down gauge and sort of you know, refine designs that are more common to what we're used to. There are other areas where aluminum does make sense, and we've seen it done in a big way with you know, competitors switching to all aluminum bodies, or we have, you know, many other applications, suspension parts and whatnot that make a lot of sense. So yeah, it's kind of all of the above right now. But yeah, I guess we'll watch and see how it plays out.
Jim, any comments on those?
Well, I think that from JP's standpoint too, that it depends on the vehicle targets. Okay, what are your targets? And then so you look at that and you got to balance that out and say, what are my options to meet those targets? And so a lot of these new materials that are being developed from the steel side, even from the aluminum side, and the processes that we're doing it are going to give us a bigger toolbox to look at and a lot of options to look at. But when we look at that thing, because I said we're material agnostic, I've worked with, well, NanoSteel, which I think NanoSteel now has been purchased by US Steel, but they're 12,000 megapascal, 50% elongation type of material. Is really interesting to look at. You have to learn to use it like everything else, but then there's some really good aluminum alloys coming out there. Some of them right now we have to warm form, but we're warm forming the boron steel. So you look at those things and you say, what makes the most sense for the vehicle targets and the cost and the weight and the performance that we get. Some of those all aluminum bodies that you see are pushing out there because those are really ride handling type of higher value type vehicles. I don't think we're going to see the all aluminum Pinto type of a vehicle out there, but it's a balance, and we got to look at plastics too. Just like Lou was saying, you know, there's advantages to that, and in the right application for the right vehicle and the targets, it's going to make the most sense to do that.
Okay, thank you very much, everybody. I think our time is really running out, but I would like to make a final closing remark. Again, I want to thank all the panelists and to join us for this discussion. We still got quite a few of the questions that we couldn't get time to answer. So let me, you know, pull those all together and we'll send to all the panelists, and we will get back to the audience. We will have a card, you know, have that listed in the website when we post these recordings. But again, you know, finally, I would like to, you know, encourage everybody to submit the entries for 2021 Enlighten Award. And here is the closing date. There will be end of the May, and then we will go through the judging process, and then we will deliver the award. I believe it's going to be in MBS, and this year probably is going to be a physical event. Okay, so that's will be it. And thank you very much, everybody, for the time to join us. Thank you, JP, thank you, Jim, and thank you, Hugh. Thank you so much.
Thank you.
Thank you.
Yeah, thanks for having us.
Thank you very much.